Okay guys, hello, here we go. We are going to look at this electrophilic substitution mechanism now. The important thing here is that you remember that you've got to generate an electrophile before we can do the mechanism. So what we are going to look at first is generating our electrophile. In this case we're going to be looking to generate an NO2 plus electrophile. So we're going to look at the nitration of benzene. And the reagents we need to use for this, they are concentrated acids. Concentrated nitric and concentrated sulfuric acid react together in this first step, if my pen works, and we generate this H2NO3 plus, and we generate an HSO4 minus. Okay, so that's the first step. The second step, and the bit we're really interested in here in terms of generating our NO2 electrophile, is the H2NO3 plus falls apart in this second stage and we make NO2 plus. So that's our electrophile and water. So there we go. At this point in this sort of reaction scheme that I'm showing here, the location of the positive charge isn't important. This next step, it becomes important. So the next step, the next thing we're going to look at here is the actual mechanism of the substitution. So to do this, we start off with our benzene ring and our electrophile, which we've just generated above, which is this NO2 species. Now notice where I'm putting this positive charge. It's on the nitrogen atom, and what happens is that's our electrophile. So what happens is we get a curly arrow coming from the delocalized ring of electrons inside our benzene ring, and we make this intermediate here. As always, drawing intermediates is very important. What's happened here, this ring has broken. We end up with what's called a horseshoe intermediate, which we draw like this. So you've got the positive charge in here, and we've got two substituents on this particular carbon. Now we've got the NO2, which we've stuck on, and it's a substitution reaction, so we need to get rid of something at this point. So we are going to lose that hydrogen, and in doing that we will bring the aromaticity back to our benzene ring. And final step, just draw this product out. So here is nitro benzene, and we've got an H plus. Why this pen isn't working is beyond me, but anyway, one of the important things you can get asked at this point is, what is the role of the sulfuric acid in this reaction? And you can say it is a catalyst, because although we're turning it into this fellow here, this anion here, we regenerate it at the end of the reaction. This H plus, this is all going on in this reaction flash, remember, this H plus will add back onto that and we regenerate our H2SO4. Okay, so that's that mechanism.